Hey guys, this is Mr. Krentz, and in this video I'm going to introduce you to the chain rule. The chain rule is a way of finding a derivative if you look at a function and you recognize that maybe it's the composition of two different functions. So if you look at y equals sine of x squared plus 5x plus 3, I think it's pretty simple to see that you could imagine this being, we have like a function u here, the kind of inside the sine, then we have the function of the sine. So I'm going to rewrite this then. I have the inside, which is my u, which is equal to x squared plus 5x plus 3. And then if the inside is u, that would give me y is equal to the sine of u. Okay, so I can break this up as like the composition of these two functions together. And if I ultimately want to find the derivative, y prime, you might think, well, maybe I can somehow do that by finding the derivatives of these smaller pieces. So here, I could take the derivative of u with respect to the variable x, and this is just a polynomial, so let's see, that'd be 2x plus 5. And then for y equals sine of u, I could take the derivative of y with respect to the variable u, and derivative of sine of u would be cosine of u. Okay. Now here's where the little trick comes into play. If I take these two derivatives and multiply them together, dy du times du dx. Okay, there's actually more going on here than we really know about, but I might look from a high level and say, well, it kind of looks like the du's would cancel each other out, and we'd end up with dy dx, which is just the derivative of y with respect to x, which is what we want to find. So I'm going to take, see, dy du is right up here. That's the cosine of u. And multiply by du dx, which is 2x plus 5. Alright, so dy dx is equal to cosine of u times 2x plus 5. I don't really want the u in there. That's something I kind of introduced in the problem. I just want x's. But we define u as x squared plus 5x plus 3. So I'm going to substitute the u back in here. So the cosine of x squared plus 5x plus 3 times 2x plus 5. All right. So in short, that's a chain rule. We're going to define the derivative of a function We can kind of split those things up, find the derivative of each. We can multiply them together, and they'll give us the derivative of the whole. Okay. Now, a slightly different way of thinking about that is this is all using Leibniz's notation of differentials, the dy, the du, and so on. I'm just going to do it a slightly different way, and in the future, I don't really care which method you choose. It's going to be kind of up to you. Now, rewrite the problem. Y equals sine of x squared plus 5x plus 3. And this time, I'm going to actually write this using function notation, the two different parts. So I'm going to identify the outside, the f of x, sine of x as f of x. And then I'm going to say that g of x is the middle. So the x squared plus 5x plus 3. Okay. This then tells me that y is equal to f of g of x, the composition of the functions, which I can write in two different ways. Okay. Now, using what we did above here, basically what I see is, we have the derivative of the outside function, so the derivative of the sine, and we keep the inside the same. And we also have the derivative of the middle. So to find y prime, we took the derivative of f and left g of x the same, and then multiplied that by the derivative of g. Okay, so basically that's kind of what we end up doing above. So if I do that for this function now, let's see. So we would have y prime is equal to the derivative of f. F is sine of x, so we get cosine. But instead of x, we replace x with g of x. So that's the f prime of g of x. And to multiply that by g prime of x. For that part, take the derivative of g, and I get 2x plus 5. Alright, it's the exact same answer we got above, but just two different ways of thinking about it. And the notation's different, and actually the notation kind of changes how we conceive the problem. I really don't care which way you choose to do. I'd practice them at both. Probably helpful to understand what both going on, but in practice you can probably end up choosing one and doing that more often than not. So up top we broke it into two different functions. We had u, which is a function of x, and we had y, which is a function of u. Find the derivative of both, multiply them together, and you get your derivative of y with respect to x. Alternatively, you can break it into different functions, f and g. Conceive of this as the composition of those two functions, and this is sometimes called then the write this down, the like an inside, or sorry, the pen's not working here. Kind of an outside inside approach, where you basically take the derivative of the outside, so that gives us the cosine, and then take the derivative of the inside, the 2x plus I, and you multiply them together.